Q7177. When flying into a strong headwind on a long glide back to the airport, the recommended speed to use is the A. Best glide speed. B. Minimum sink speed. C. Best lift/drag speed plus half the estimated wind speed at the glider's flight altitude. The correct answer is C. When flying a glider into a strong headwind during a long glide back to the airport, it is important to optimize the glide performance to maximize ground covered and minimize time spent in the air. Here's the reasoning behind this recommendation. Best lift/drag speed. The best lift/drag speed is the airspeed at which the glider achieves the maximum ratio of lift to drag. This speed represents the most efficient glide performance, where the glider covers the maximum horizontal distance for a given vertical descent. Wind adjustment. Since the glider is flying into a strong headwind, it is beneficial to adjust the glide speed to account for the wind's effect on ground speed. Adding half the estimated wind speed at the glider's flight altitude helps to compensate for the headwind component, allowing the glider to maintain an effective ground speed. By combining the best lift/drag speed with the wind adjustment, the glider pilot can optimize the glide performance to make efficient progress towards the destination airport. This technique considers both the glider's inherent aerodynamic performance and the influence of the headwind on ground speed. It's important to note that the specific recommended speed may vary depending on the glider's characteristics, wind conditions, and pilot experience. Pilots should refer to the glider's flight manual, manufacturer's recommendations, or specific guidance provided by their flight instructors or clubs. 7192. What is the suggested speed to fly when passing through lift with no intention to work the lift? A. Best glide speed. B. Minimum sink speed. C. Best lift/drag speed. The correct answer is B. When flying a glider, encountering areas of lift is not uncommon. Lift is rising air that can provide additional lift and potentially prolong the flight. However, there may be situations where a glider pilot does not intend to work the lift and instead wants to continue on their planned course or destination. In such cases, it is important to maintain an efficient speed that minimizes the sink rate, allowing the glider to pass through the lift with minimal altitude loss. The minimum sink speed is the airspeed at which the glider experiences the least amount of sink rate, maximizing the glider's glide performance. It represents the speed at which the glider achieves the lowest descent rate for a given amount of forward progress. By flying at the minimum sink speed when passing through lift without working it, the glider pilot can minimize altitude loss and make efficient progress towards their intended destination. This speed allows the glider to take advantage of the lift briefly while reducing the sink rate and preserving altitude. It's important to note that the specific minimum sink speed may vary depending on the glider's characteristics, weight, and other factors. Pilots should refer to the glider's flight manual or specific guidance provided by their flight instructors or clubs for the recommended minimum sink speed. 7186. Unless adequate speed control is maintained during the turn to base and the final approach for a landing into the wind, which would most likely occur if a steep wind gradient existed. A. The desired landing spot would be undershot or the glider would stall. B. The airspeed on final approach would increase, causing the glider to overshoot the desired landing spot. C. The wingtip on the outside of the turn would stall before the wingtip on the inside of the turn. The correct answer is A. When flying a glider in a steep wind gradient, where there is a significant change in wind speed or direction with altitude, it is crucial to maintain proper speed control during the turn to base and final approach for a landing into the wind. Here's the reasoning. Steep wind gradient. A steep wind gradient refers to a rapid change in wind speed and direction with increasing altitude. This can occur due to various atmospheric conditions, such as temperature inversions or localized weather phenomena. Inadequate speed control. If the pilot fails to maintain adequate speed control during the turn to base and final approach, two potential outcomes can arise. A. Undershot landing. If the glider's airspeed is too low, it may not have enough energy to reach the desired landing spot. The glider could fall short and undershoot the intended touchdown point. B. Glider stall. If the glider's airspeed drops below the stall speed due to inadequate speed control, the wings can lose lift, resulting in a stall. A stall can lead to a loss of control and an undesired landing outcome. To avoid these risks, it is crucial for the glider pilot to maintain proper speed control, ensuring sufficient energy for the approach and landing into the wind. This may involve adjusting the airspeed based on the wind gradient, making appropriate control inputs, and anticipating the potential impact of changing wind conditions. It's important to note that the specific techniques and procedures for speed control may vary depending on the glider's characteristics, pilot training, and specific guidance provided by the glider manufacturer or instructor. 7187. A rule of thumb for flying a final approach is to maintain a speed that is A. 50% above the glider's stall speed, regardless of wind speed. B. Twice the glider's stall speed plus half the estimated wind speed. C. 50% above the glider's stall speed plus half the estimated wind speed. The correct answer is C. When flying the final approach in a glider, it is essential to maintain an appropriate airspeed that ensures safe and controlled flight. Here's the reasoning. Glider's stall speed. The glider's stall speed refers to the minimum airspeed at which the wings can maintain lift before stalling. It is an important reference point for determining safe operating speeds. Rule of thumb. The given rule of thumb suggests maintaining a specific airspeed during the final approach. According to option C, this speed should be 50% above the glider's stall speed plus half the estimated wind speed. Speed considerations. The rule of thumb incorporates two factors for determining the final approach speed. A. 50% above stall speed. The airspeed chosen for the final approach should be 50% higher than the glider's stall speed. This provides a safety margin and ensures that the glider remains above the stall speed during the approach, even in the presence of variations or unexpected changes in wind conditions. B. Half the estimated wind speed. Additionally, half the estimated wind speed is added to the glider's stall speed. This accounts for the effect of wind on the glider's ground speed and helps ensure sufficient control and maneuverability during the final approach. By following this rule of thumb, glider pilots can maintain an appropriate airspeed that allows for safe handling, effective control, and a margin of safety during the final approach. It's important to note that this rule of thumb provides a general guideline, and that specific glider types and flight conditions may require adjustments to the final approach speed. Pilots should refer to the glider's flight manual and receive proper training and guidance from flight instructors to determine the appropriate final approach speed. 7188. If swirling dust, leaves, or debris indicate a strong thermal on the final approach to a landing, it is recommended that the glider pilot A. Open the spoilers and reduce the airspeed. B. Close the spoilers and increase the airspeed. C. Open the spoilers and maintain a constant airspeed. The correct answer is B. When flying a glider on the final approach to a landing, it is important for the pilot to be aware of the surrounding air currents and weather conditions. Here's the reasoning. Indication of strong thermal, swirling dust, leaves, or debris can be indicative of a strong thermal, which is an upward current of warm air. Thermals can provide lift to gliders, but they can also affect the stability and control of the aircraft. Closing spoilers. Spoilers are devices on the wings of a glider that can be extended to disrupt the smooth airflow and reduce lift. By closing the spoilers, the glider pilot decreases the amount of lift generated by the wings. This can help prevent the glider from being excessively affected by the strong thermal and maintain better control. Increasing airspeed. Increasing the airspeed of the glider can further enhance the pilot's control and stability. The increased airspeed provides more dynamic pressure on the control surfaces, making the glider more responsive to control inputs and reducing the impact of sudden thermal-induced disturbances. By closing the spoilers and increasing the airspeed, the glider pilot can maintain better control and stability during the final approach, even when encountering a strong thermal. This allows for a smoother and more controlled landing. It's important to note that specific procedures and techniques may vary depending on the glider's characteristics, pilot training, and guidance provided by the glider manufacturer or instructor. Pilots should adhere to the recommendations outlined in their flight manuals and receive proper training for managing different weather conditions and thermal activity.